In the vast catalogue of cosmic chemistry, certain laws appear unbreakable. One of them is this: nickel and iron are always formed together. Whether in supernova explosions, the cores of dying stars, or interstellar debris, these two elements are cosmic twins. Forged side by side, their ratio consistent across millions of observations. So when NASA's latest data on 3I Atlas revealed the presence of nickel, and not a trace of iron, the reaction within the scientific community was not excitement but disbelief. Professor Avi Loeb, a leading voice in astrophysics, immediately flagged this as one of the most alarming anomalies. In his view, this chemical imbalance isn't just strange, it's unnatural, because in the known universe there is no environment where you get one without the other, unless it's been engineered that way. To make matters more complex, the concentration of nickel detected wasn't small, it was significant, enough to suggest that this wasn't contamination or a statistical error. And when asked about potential natural explanations, Loeb offered a sobering perspective. The only known material on Earth with similar nickel dominance exists in aerospace alloys, advanced human-made materials designed for heat resistance and strength. So the question becomes, how does an object, hurtling into our solar system from deep space, carry a signature of chemical engineering? Some suggest that the nickel could come from a unique star system, one with exotic conditions, but no star, no nebula, no cosmic furnace has ever produced a signature like this. What remains is a gap in our understanding, or a challenge to our assumptions. If this composition is real, 3I Atlas may not be a comet at all. It may be a construct, or a relic, left behind by something else entirely. Size is not just a number. In astronomy, it determines everything, from mass to trajectory to whether something is harmless or history-altering. So when the early estimates of 3I Atlas placed its core at roughly 2.8 kilometers in diameter, they'd already made it a substantial object. But new independent analyses, particularly from radiometric and gravitational modelling, have disrupted that assumption completely. Some teams now estimate the core could exceed 50 kilometers in diameter. That's not just a rounding error. That's an order of magnitude leap. And it changes everything we thought we understood about 3I Atlas. Avi Loeb, who has reviewed these numbers closely, pointed out a contradiction. An object of that size should have been visible much earlier. It should have reflected more light, produced stronger gravitational interactions, and revealed a far more dramatic energy profile as it approached the Sun. But none of that happened, which leads to an unsettling possibility, one that experts are only now beginning to consider. Perhaps 3I Atlas is cloaking its true mass. Or worse, perhaps it doesn't behave like a normal object at all. If it's hollow, fractured, or composed of unknown materials, our size detection models simply wouldn't apply. And if that's the case, then every calculation based on brightness, rotation speed, and mass decay would be flawed. Loeb calls this the quiet paradox, the idea that the largest interstellar object ever recorded is also one of the most invisible, operating just below the detection thresholds we've built for conventional space debris. Either our technology is inadequate, or 3I Atlas has properties we weren't prepared for. Because if this truly is a 50-kilometer body travelling on an intentional trajectory, then its silence is not natural. It's designed. For centuries, astronomy has been grounded in Newton's laws and Einstein's refinements, motion explained by gravity, acceleration caused by mass, and comets propelled by evaporation. But in the case of 3I Atlas, that framework is beginning to falter. Multiple datasets, including those from MAVEN, SOHO and James Webb, have registered subtle but persistent deviations in the object's speed. These deviations cannot be explained by outgassing, the usual cause of momentum changes in comets. There's no detectable thermal plume, no loss of visible material, and no correlation with solar heating patterns. Yet the trajectory is changing. Professor Avi Loeb doesn't mince words. He considers this non-gravitational acceleration one of the most important red flags in the entire 3I Atlas dossier. If real, and confirmed with further data, it would mean that something is pushing or steering this object from within. In his peer-reviewed paper, Loeb outlines several scenarios. One involves an internal energy source, possibly a mechanism we don't yet understand, capable of emitting force without mass loss. Another leans toward interaction with solar plasma, magnetic forces, charge separation, or other exotic electromagnetic effects that we've only seen in laboratory conditions. And then there is the most controversial possibility: intentional control. If 3I Atlas is not a natural object but something engineered, ancient, dormant, or even autonomous, then this non-random acceleration could be its first detectable act of navigation. That doesn't mean it's alive, but it does mean it's active. For now, mainstream scientists are cautious. Most still prefer to model the changes as statistical noise, but the anomaly persists because an object that accelerates, without mass loss, without spin change, and without thermal signature, breaks every rule we know. And that's exactly what makes it dangerous. Comets, when heated by the sun, vent gas and dust through jets. Chaotic streams of material pushed out by internal pressure and thermal reaction. These jets are usually wild, disorganized, and change position as the object spins. But 3I Atlas is different. Its jets are sharp, stable, and eerily straight, and that's a problem. Initial high-resolution images, especially those from amateur astronomers during the mid-November alignment, captured something deeply unusual. The jets emerging from 3I Atlas didn't fan out like traditional comet tails. They were narrow columns, some appearing to pulse with precise regularity. More importantly, they didn't shift as the object rotated. Professor Avi Loeb points to this as a potential indicator of internal regulation. In a typical rotating body, gas jets drift with spin, creating spirals or clouds. But 3I Atlas has a rotation period of roughly 16 hours, confirmed across multiple observatories, and yet its jets remain directionally fixed. This suggests that the emission isn't just a thermal accident. It's either being stabilized by electromagnetic fields, or, in the most controversial theory, it is actively controlled. One hypothesis is that the jets aren't just gas, but structured plasma, guided along invisible magnetic filaments that behave more like propulsion columns than chaotic outgassing. If that's true, then the object may be generating a weak but purposeful magnetic field, not unlike ion thrusters used in advanced spacecraft. Other scientists have dismissed the pattern as an observational illusion, but the consistency across independent recordings makes that unlikely. And when the jets ignite more strongly after CME impacts, rather than weaken, it hints at an internal logic we don't yet understand. Stable jets, no wobble, no dispersion, no explanation. And when natural behavior doesn't fit, we must ask, is it natural at all? In the age of near-instant satellite telemetry and real-time telescope feeds, a 45-day delay from NASA in releasing 3I Atlas images raised more than just eyebrows. It raised suspicion. When the public finally saw the official images, they weren't high-resolution or revealing. They were faint, hazy, almost evasive. But what caused even greater concern was the silence that preceded them. For nearly 7 weeks, no press updates were issued, no technical breakdowns released, and no substantial commentary made by NASA, despite the object drawing international scientific interest. Professor Avi Loeb voiced what many others were thinking. This was not a failure of equipment. This was a decision. According to him, if this had been an academic mission or private institution, data would have been processed within hours and published online, regardless of government closures. But NASA, as a bureaucratic institution, operates under different rules. What's more troubling is the timing. During this blackout window, several independent observers, using small telescopes, began detecting strange activity, multiple jets, a growing halo, and even suspected trajectory shifts. These were the very moments NASA should have been the loudest. Instead, they were silent. Loeb acknowledged that part of the delay may have stemmed from the US government shutdown, which froze non-essential operations. But even that excuse falters when you consider that Mars images from the same agencies were released just days after capture, even during the shutdown. So, was this a matter of caution, or was it a matter of control? What many now wonder is this. Did NASA see something in the early data that they didn't know how to explain? Something they weren't ready to share? Because in science, silence is not just absence. Sometimes, it's containment. On November 22nd, a solar storm made contact with something not just in the path of the sun's fury, but deeply embedded in our current mystery. A coronal mass ejection, or CME, hurled billions of tons of charged particles directly at 3I Atlas. Normally, Such an impact deforms a comet's tail. It can scatter plasma, disconnect charged filaments, or even erase jets from visibility for days. But when the CME struck 3I Atlas, something else happened entirely. The object lit up. Observers around the world noticed a sudden intensification. Jets sharpened, the halo grew, and the core, which had appeared dormant just days before, began showing patterns of energetic behavior far beyond what its solar distance should justify. This isn't speculation. The Solar and Heliospheric Observatory, amateur astronomers, and deep space tracking stations all recorded a jump in brightness, shape complexity, and magnetic turbulence, and the timing was no coincidence. The surge began immediately following the predicted CME impact window. So what does that mean? Some believe it confirms that 3I Atlas is wrapped in an electromagnetic environment far more complex than we understood. Others suggest the object's structure, potentially hollow or semiconductive, amplified the CME's effect in ways never before observed. And then quietly a new theory emerged. What if this wasn't a reaction, but an activation? What if the CME served as a trigger, not for a natural response but for a dormant system, something latent, buried, waiting? Professor Avi Loeb didn't call it artificial. He didn't need to. Instead, he focused on the physics. No natural comet responds this way. No known material structure ignites into symmetry after a plasma hit. And once again, we're left with only questions, sharper than the jets now burning across the void.